Do the maths. Is there a market position from solving this hard problem? A back of the envelope way to price the cost of leaving it unsolved. Some hard problems remain hard because the cost of solving them is too high to act on. Others remain hard because no one can agree on what leaving them unsolved is costing. Carbon has been the second kind for most of the last 2 decades, which is why it has largely been treated as a compliance obligation rather than a market position. The argument has long been about the number. That argument now has a peer-reviewed anchor. The argument becomes about who will find the market position. A defining moment in time. There is a moment in any hard problem when the cost of solving it structurally drops below the cost of leaving it unsolved. That moment can be calculated, not guessed. The cost of the solution falls as technology deflates and verification gets cheaper. The cost of the status quo rises as the problem compounds and institutional alternatives exit. Both curves are moving. The crossing is the crossover point, and it arrives earlier than a static comparison would suggest, because both curves are in motion at the same time. For most of the last 2 decades, carbon could not be read this way. The cost of the status quo, what the global system was actually paying to leave emissions unpriced, was a contested number. Estimates of the social cost of carbon ranged so widely and rested on so many disputed assumptions that no finance minister, no procurement officer, and no corporate board could put a defensible figure on what the problem was costing. That uncertainty was the real choke point. It kept the entire carbon debate stuck in an argument about whether the number was real, rather than what the number unlocked. In March 2026, Marshall Burke and colleagues at Stanford resolved that argument. The technical details are dense, yet the headline is straightforward. A peer-reviewed paper in Nature produced the most rigorous quantification to date, a central estimate of the social cost of approximately $1,013 per tonne of CO2 under conservative assumptions, at a 2% discount rate with no impacts past the year 2100, rising to $3,448 under continued post-2100 growth effects at the same 2% discount rate, and to $7,822 under Ramsey discounting through to the year 2300. That central figure is an order of magnitude higher than the bottom-up estimates currently used by the US federal government and well above the prices in any operational carbon market on Earth. And the authors are explicit that these figures are conservative. They measure GDP losses only. They do not capture biodiversity collapse, cultural displacement, loss of ancestral homelands, sea level rise, or the full weight of extreme weather events. The paper itself states that our damage estimates will understate the total damages associated with historical and future emissions, perhaps substantially. Speaking to reporters at publication, co-author Noah Diffenbauer put it plainly: we haven't accounted for impacts that aren't captured in GDP, such as biodiversity and cultural homeland, and our approach also underweighs some sources of climate impacts, such as sea level rise and some types of extreme events. This makes our estimates conservative. The central figure is also, in the author's own framing, much larger than recent bottom-up estimates by the US federal government, roughly 5 times the EPA's most recent figure under comparable assumptions. The unpriced cost is higher. It just hasn't been quantified yet. The second curve now has a peer-reviewed anchor. Pricing the status quo. The Burke number does something specific. It's not a bill you can hand to a single client or customer. An airline cannot tell a passenger, we are adding a charge because your flight's emissions cost $1,013 per tonne, because the damages from that tonne are shared across the whole planet and over many years, not just borne by the person buying the ticket. The same is true everywhere. The real cost of carbon is distributed across populations, ecosystems, and timescales. No single buyer sees on their own balance sheet. What the number does is anchor a trajectory that was previously a directional argument. The Burke figure is an anchor price and a liability ceiling that exerts upward pressure on every adjacent cost in the carbon stack over time. Every cost currently rising. mandatory climate disclosure compliance under regimes like Australia's AASB S2, the EU Corporate Sustainability Reporting Directive, California's SB 253, rising landfill levies, insurance premium differentials on climate-exposed assets, Scope 3 pushdown from major corporate buyers, ESG claim legal exposure. It's all rising because the underlying systemic cost is in an order of magnitude higher than anyone previously priced it. Burke and his colleagues have measured the pressure that is pushing these client-level costs up. A few concrete figures from the paper illustrate what this trajectory looks like when translated into specific actors. 1 tonne of CO2 emitted in 1990 caused approximately $180 in global damages by 2020. The same tonne will cause an additional $1,840 through to 2100. The historical damage was less than 10% of the total debt. US emissions since 1990 have caused approximately $10.2 trillion in cumulative global damages by 2020, with about 30%, which is $2.97 trillion US dollars, felt inside the US itself, and 14%, $1.39 trillion US dollars, in the European Union. Aramco's 1998 to 2015 emissions alone represent an estimated $3 trillion in cumulative global damages realized by 2020, roughly 8 years of company revenue rising more than 20-fold to $64 trillion US dollars by the end of the century if those emissions remain in the atmosphere. The distributional picture is clear. Per capita emissions data from global inequality research places the top 0.1% of global emitters at over 290 tonnes of CO2 per person per year. The poorest 50% at roughly 0.7 tonnes. Applying the Burke central social cost to those figures produces approximately $294,000 US dollars in annual damages caused per person in the top 0.1% against roughly US $710 per person in the poorest 50%, a 400 to 1 ratio between the populations that contribute most and the populations that bear the consequences most heavily. As mentioned above, these numbers are conservative. They are the price GDP component only. The full cost is larger and not yet reducible to a single figure. The cost of solving is collapsing. While the second curve was being priced, the first curve was falling. 3 cost categories, monitoring, verification, and payment, historically made carbon markets expensive to build and easy to contest. All 3 are now approaching marginal costs that round to zero. Monitoring is now satellite native. Commercial archived imagery now cost in the range of 10 to 20 US dollars per square kilometre, with fresh tasking typically in the range of US 20 to $40 per square kilometre for sub-metre resolution. A decade ago, that capability sat exclusively with institutional field missions and cost orders of magnitude more. Verification is now cognitively cheap. Frontier equivalent inference costs have fallen in the range of 90 to 90% between early 2024 and early 2026 across multiple benchmark series. The cognitive layer required to process and verify disclosed data at scale now costs almost nothing at the margin. Digital identity registration has fallen from over $20 US dollars per person to under $1 US dollar per person at national scale, making it possible to attach verified emission data to specific transactions, assets, and producers. Payment has scaled further than most observers have registered. India's UPI processed 22.64 billion transactions in March 2026, a record high and a 24% year-on-year increase in volume. Brazil's Pix has onboarded 93% of the adult population and now processes more daily transactions than Visa and MasterCard combined. Kenya, Peru, Namibia, and Trinidad and Tobago are running on licensed derivatives of the same infrastructure. Outcome-linked capital can now be routed to the specific populations at cost the old architecture could not match. Burke and colleagues themselves identify this as an open avenue, noting that well-developed opportunities for transfer payments also exist outside the international system, such as bilateral low-cost transfer payments to the mobile phones of low-income households in developing countries. Monitoring, verification, and payment. 3 pillars. All 3 have crossed the threshold where cost is no longer the binding constraint. How to calculate a market position in carbon. Put both curves in the same frame and a specific claim becomes possible for the first time. A graph is shown in the article. The cost of the status quo in carbon is priced at roughly $1,013 per tonne globally, rising and conservative. The cost of verifying, monitoring, and contracting against a tonne has fallen to a level where the architecture to deliver a price verified unit, 1 tonne verified and reported, 1 asset tracked with full material provenance, 1 disclosure ready procurement decision is commercially deliverable at a cost well below what the system is already absorbing. Putting a number on the second curve, the cost of leaving carbon unsolved is what makes it possible to see when solving becomes cheaper than not solving, and to treat that gap as a market opportunity. When it is cheaper to solve, you can create offers that finance ministers, procurement officers, and corporate boards will listen to. Offers that can be written into real contracts. That is the crossover point. The Burke paper, published in March 2026, is what makes it calculable. The framework's own contribution, in the author's words, is that the approach aligns the financial accounting framework of L&D with the existing SC CO2 framework. That alignment is what turns a contested number into something legible to courts, disclosure regimes, and insurance underwriters. And it is what Diffenbaugh himself signals when he notes that the work clarifies the cost-benefit analysis of potential solutions. The number is no longer just a damages estimate. It is a basis for calculating whether a given response is worth doing. And because the outcome unit, 1 verified tonne, is the same across every sector where carbon is embedded, the addressable market sits beyond one industry. It is the full global economy priced at the full social cost of emissions, rising on a measured trajectory. For the first time, a market position in carbon can be calculated. The number is large, the number is global, and the number is conservative. Calculating the market is the first step, not the solution. An important qualification: a calculable market position is not the same as a solved problem. What the calculation establishes is that it is now commercially viable for the market to solve the problem at a cost below what the system is already paying to leave it unsolved. That is a necessary condition. It is not a sufficient one. Carbon remains a hard problem, and it is hard for specific reasons. It crosses borders, which means no single jurisdiction can price or enforce it comprehensively. It compounds over timescales longer than political cycles and corporate strategy horizons. It distributes damage asymmetrically, hitting populations that did not cause it and have little capacity to absorb it. It requires coordination across actors who have no prior history of coordinating and limited reason to trust each other. And it sits across public and private boundaries in a way that makes both pure market and pure state solutions structurally incomplete. These are coordination problems, legitimacy problems, and trust problems. They are the class of problems that mandates, money, and market failures have a long history of failing to solve. The open question, now that the market can be calculated, is what kind of actor will occupy the position? What soft power has already solved? The useful signal sits in adjacent spaces where the same class of problem is hard, cross-border, coordination-heavy, and trust-dependent, and has already been crossed. 3 cases are relevant references because each demonstrates a specific dimension of what carbon now requires. Pricing, the outcome unit. Living goods. Child survival in sub-Saharan Africa was for decades The archetypal case of a hard problem that money and mandates could not fix. Billions of dollars in donor funding, state health system budgets, and multilateral program delivery produced activity without accountability. Inputs retract, outcomes were not. Living goods changed the calculation. A 2021 randomized controlled trial covering 4,500 community health workers serving 3.6 million people in Uganda established that a compensated, digitally supervised CHW architecture produced a 30% reduction in under 5 mortality and a 27% reduction in infant mortality. The Kenyan government moved the model from externally funded project to country contracted public service. The shift was not driven by mandate, it was driven by arithmetic. The market opened because the outcome unit was priceable and the ratio was defensible. Carbon has just had its RCT moment. Burke and colleagues have priced the outcome unit at an integrity standard a government buyer can defend. Verification without intermediaries. HALA systems. For decades, accountability for wartime atrocities depended on institutional chains of custody, human observers, NGO field missions, UN verification, state-mandated tribunals. Each required physical access, institutional backing, and months of verification before evidence could be submitted. The choke point was physical and institutional. HALA systems dissolve that choke point by replacing the chain of custody with a chain of provenance structured by code. Cryptographic verification removed the need for the observer. The question shifted from who collected this evidence and can we trust them to has this data been altered since it was recorded? A court can answer the second question without an institutional intermediary. The world's first ICC Article 15 dossier featuring cryptographically secured evidence was submitted through this architecture. The evidentiary standard is now mathematical rather than reputational. Carbon faces the same verification problem at enormous scale. Every ton of embodied carbon, every verified avoided mission, every traded credit requires a chain of provenance that currently depends on institutional trust and currently collapses under sustained scrutiny. The architecture that proved itself in conflict zones, where every data point is actively contested, is precisely the architecture that carbon verification now requires. Coordination against asymmetric harm. Tustan. For decades, international attempts to address female genital cutting and child marriage in West and East Africa relied on legal bans, state enforcement, and awareness campaigns. Each required either state capacity to enforce compliance or individual conviction to change behavior. Neither addressed the actual problem. A family that abandoned a harmful norm alone faced prohibitive social and economic consequences that law and information could not protect against. Tostan demonstrated that the problem was solvable, but not by hard power. It was a coordination problem. When a critical mass of community members could publicly commit together, the social equilibrium shifted and the new norm became the lowest cost choice. Over 10,000 communities across 8 countries have now publicly declared abandonment. A UNICEF evaluation confirmed the change, held 8 to 10 years after the intervention ended, with no further programming. The government of Senegal integrated the model into national strategy. 10 UN agencies adopted it as a reference framework. Carbon redistribution is the same class of problem. The payment rails now exist. UPI, PIX, and their licensed derivatives can now route low-cost transfers to mobile phones of low-income households. The measurement science now exists. What is missing is the coordination layer that routes priced outcome payments from the populations causing damage to the populations bearing it. That coordination layer cannot be built by the institutions that failed to deliver climate finance under the old architecture because they still operate under the constraints that made them fail. It has to be built by actors who can hold credibility across jurisdictions, operate without institutional sponsorship, and verify outcomes in a way the capital can contract against. That is precisely the class of actor that has already solved the adjacent problems. What this means for capital allocation. The carbon space has just completed a transition that took child survival in Africa 2 decades, conflict evidence a decade, and a norm change in West Africa 20 years. The outcome unit is priceable. The crossover point is documented. The payment infrastructure is operational. The verification architecture has already been battle tested in a harder environment. The implication for capital is more pointed than the general argument suggests. The Burke number is not a price target. The investable thesis is not buy credits until they converge on 1,013 US dollars. The investable thesis is that the gap between the market price and the true damage will be closed by litigation, disclosure, and insurance repricing, not by voluntary market convergence. That changes where capital should sit. Even on conservative assumptions, the order of magnitude is clear. For example, human activities released roughly 53 gigatons of CO2 equivalent in 2024, all greenhouse gases on a CO2 basis per the UNEP emissions gap report. If just 5% of that annual flow ends up under contract, disclosures, or insurance models that reference Burke level pricing in some form, that is a notional 2.7 trillion US dollars of damage per year at 1,300 US per ton. A verification native platform that intermediaries even 0.5% of that value as fees will be looking at an annual revenue line in the order of 13 US billion. The exact numbers will move, the order of magnitude will not. These are order of magnitude illustrations, not forecasts or investment advice. That in turn clarifies where in the stack capital should sit, not in the commodity layer, offset portfolios and credit generation assets in thin premium markets. Yes, in the intelligence layer, MRV infrastructure, provenance systems, disclosure software, and coordination rails, the architecture that makes the gap enforceable. And the timing signal is not the carbon price curve, it is the disclosure calendar. AASB S2 Group 1 reports are being filed now. Group 2 reporting begins 1 July 2026. California's SB 253's first Scope 1 and 2 reports are due on the 10th of August 2026. Those venues, courts, disclosure footnotes, and insurance underwriting models are where the Burke number becomes a financial reality. The investment horizon matters, and it's from 2026 to 2028, not 2030 and beyond. Beyond carbon, the calculation that opened the carbon position is not specific to carbon. It is the same calculation that opens any hard problem. Define the outcome unit, price the cost of the status quo, measure the cost of structurally solving, and identify the point where one drops below the other. Carbon is the largest case currently calculable. It is not the only one. The soft power index has mapped 12 hard problem fields where the crossover point has been reached or is approaching. Among them, antimicrobial research, where one institutional payment choke point suppressed a 28 to 1 return for 30 years until the NHS subscription model changed the logic in 2024. The learning crisis, where verified literacy outcomes can now be priced at 12 US dollars per child, and access to justice, where 5 billion people are excluded from basic legal services and digital paralegal networks are starting to close the gap. Each is calculable. Each has an outcome unit, a crossover point, and a market position waiting to be held. Who moves first? The cost of the hard problem can be calculated. The second curve has a peer-reviewed anchor for carbon. The market position is defensible. The first step, calculating that the market exists, is done. If you're a corporate investor, builder, or operator, the move is the same. Consider competing beyond the commodity layer of offsets and capital. Build, buy, or back the infrastructure that lets the governments and companies prove in contracts and orders that they are structurally reducing their future carbon liability. The MRV, provenance, disclosure, and coordination systems that make Burke level pricing usable. That is where growing demand for solutions that reduce disclosure, legal, and insurance costs will meet a constrained supply of credible options. What happens next depends on who moves while the position is still open. Hard problems are where the next generation of defensible market positions will be built. That is where leaders seeking positive sum outcomes will focus. The work is to find the market in the mission.